All right, welcome back, everybody. This is Difference of Squares, the intro. And when we're talking about difference of squares, first of all, we need to recognize square numbers. So we've talked about x squared a lot, but we haven't really discussed perfect square numbers very much. I know, for example, we said that 5 squared was 5 times 5. I know that we did that in the past. What is 5 times 5? 25. And so you can see on this list here that 25 is 5 squared. And all the numbers on this list are perfect squares. And I kind of dislike that they're already written down for you because there's some element of it would be nice if we kind of had to go find them. But what is 1 the perfect square of? It's just 1 times 1. It's 1 squared. And this is going to be a pretty easy thing to fill out, you'll recognize. But 4 is 2 squared. Because 2 times 2 equals 4. And what is 9? 3. 3 squared. Because 3 times 3 equals 9. And 16 is, right, and basically we're just counting up at this point, but I want to just kind of pause you for a second. Don't just write 6 squared, 7 squared, 8 squared, 9 squared. Make sure that you kind of are forming connections. 36 is 6 times 6. Let's say this number, 49. Sounds like a weird number. That one was always one that was easy for me to remember because it's just such a weird number. 64. 64 is 8 times 8. And 81. 81 is 9 times 9. And 100 is 10 times 10. And then we get to 121, which is 11. You may have never heard that one before. And here is pretty much the highest that you need to memorize, 144, which is 12. Fair game for all of these to be on the quiz tomorrow. The good news is that you have Desmos. And so if you ever get to one you're not sure, you can just go to Desmos. You can type SQRT for the square root. And then you can type in whatever you want, like maybe 81, and it'll tell you 9. You can type in 100, and it'll tell you 10. You can even type 225, and it'll tell you 15. Now, here's the thing about perfect squares. There's not a lot of them. For example, which number in the 70s is a perfect square? None of them. 70 doesn't work. 71, 72, 73, 74, 75, 76, 77, 78, 79. Not a single number in the whole 70s is a perfect square. They're kind of rare. They're like little special numbers, okay? Hopefully, the more that you learn math, when you get to geometry, especially when you get to Algebra 2, and you start to memorize these perfect squares, when you see a perfect square out in the world, you kind of go, oh, cool, that's a perfect square. I'll be honest with you, my home address is 121. And I won't tell you the street that it's on, but 121 is my house number, which is a perfect square. And when we went to tour the house, when I was going to buy a house, I was like, oh, look at that. Look, it's 121. That's a perfect square. That's a great house for a math teacher to live at. And I know that's silly, but once you memorize the perfect squares, you want it to be like little treats. Like, ooh, I can see, oh, look, I'm at McDonald's and my receipt says I'm order number 36. Nice, that's a perfect square, right? So I know that's corny, but perfect squares, it's nice to kind of learn them. There are, like I said, not very many. So whenever you see them, it's kind of like, ooh, there's a perfect square right there, okay? So for example, when I see a question like number 1, I'm like, oh, 49, nice, that's a perfect square. Okay? And so when you look at all of these here, Nice, that's a perfect square. Nice, 25, that's 5 times 5. 36, that's 6 times 6. 16, that's 4 times 4. And 81, that's 9 times 9. All of these are perfect squares. Okay? So, what makes a difference of squares? Very particularly, this is a very specific setup. First of all, difference. What does difference mean in a math class? Subtraction. So this must have a, I don't really know if this is going to look great in there to just put a dash like that. I'm probably also going to put, that's really hard to read because my handwriting's terrible, must have a minus. Okay? So look at this. You must have a minus. Look at every single question down here. Minus, 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 minus. What happens if there's a plus? There's not. there's not a plus. It's a minus every time. Okay? And then if it's called the difference of squares, both terms must be perfect squares. Oh, off the screen. So if we have a subtraction of perfect squares, we'll go back, put it in the middle of the notes. If we have a subtraction of perfect squares, now this is going to be a little bit rare in reality, but on your quiz tomorrow, you're going to have 5 questions like it. If we have a perfect subtraction of squares, the first thing I like to do is put a minus and a plus. So do this with me. Put your minus and your plus here. Does it matter which order you put them in? Nope, it does not. You can put the plus in the first position, you can put the minus in the first position, but you have to have one of each. So 1 minus and 1 plus. I don't care if you do the minus first, I don't care if you do the plus first, but you got to have one of each. Now for this question, it says a squared, which is a times a. So we're just going to put an a in the first position and an a in the second, in the first position of the second parentheses. And then over here we have b and b, so we're going to put b and b. So when we do difference of squares, don't let this overcomplicate it for you. You're going to put a minus and a plus, and then you're just going to take those square roots, you're going to figure out what makes those squares, and you're going to break it down. So I'll show you how easy this is. These questions should take about 10 seconds each, because we don't even need Desmos unless we haven't memorized the squares. But on our paper, there's an entire list at the top of all the squares. So look at this question. Whoa, there's 2 things. Do we have a minus in the middle? Yes. And what about all the terms? Are they all perfect squares? Is x squared a perfect square? Yes. We have a minus? Yes. Is 49 a perfect square? Yes. So here goes 10 seconds, parentheses, parentheses. One of them's a minus, one of them's a plus. It doesn't matter what order. What is x squared when you kind of rip it in half? It's just x and x. And what is 49 when you kind of rip it in half? It's 7 and 7. And that's it. That's the whole question. You're done. All you have to do is write the parentheses. One of them's a minus, one of them's a plus, and then you just kind of rip it apart. Now, when you do this, just keep everything in the same position. So since the x comes first, x comes first, x comes first. Since the 49 comes last, 7 goes last, 7 goes last. You just keep everything where it is. So let's do number 2. If you haven't already, I'm sure there's some people in class that have already knocked out a lot of these questions. parentheses. One of them's a minus, one of them's a plus. Because the 25 is perfect, the x squared is perfect, the minus is perfect, the 36 is perfect. So, up first is 25. Rip the 25 into two pieces. What do you get? 5 and 5. And because the 25 goes first, the 5 goes first. Up next is the x. Rip that in half. There's two of them, so it's going to be 1 and 1. Then we have the minus, so now we have our signs. And then we have our 36. Square root that into two pieces, 6 and 6. And that's the whole question. All you have to do is break things in half. So, we're going to do question number 3. I'm going to give you some time to do it. This question is not mega easy. There is something a little bit different about it. But just keep everything in the same order. Go one piece at a time. Let's also make sure that our headphones and phones are put away, especially during the notes. Hopefully these are... You got it. Remember that? What are we doing? Do you have any written parentheses down?
No, I didn't.
At the very least, you should have the parentheses. And every single question has a minus and a plus. So you should already have a minus and a plus. Right? Every single question is like that. You don't even have to think to put that stuff down. Okay, let's see this. So, we have the 16, the 81, the x squared. 16, perfect. Minus, perfect. 81, perfect. X squared, perfect. So in this order, break them down. I like to start with my minus and plus. The first thing I see is a 16. What happens when I square root that 16 and rip it into two parts? I get 4 and 4. So the 16, completed. What comes after the 16? It's the minus sign. Okay? 4, then the minus. After the minus is an 81. And what happens with 81 when we square root it into those two pieces? 9 and 9. That's coming after the minus because it's after the minus. And this question, the last thing, is an x squared. And rip that into two pieces. We're going to have x and x. And yeah, the x can go last. That's okay. It doesn't matter as long, well, it doesn't matter which order that the question makes you do it in. You have to do it in the correct one. But if the x comes last, that's fine. The x comes last. Okay? 4 and 5 have small little differences here. Number 4 has 144. Is that a perfect square? Mm-hmm. Yes. It has x power 4. Right. Can we rip that in half into two pieces? Yeah, it would be x squared and x squared. So that's perfect. And the minus is perfect. Is 1 a perfect square? 1 is right here. 1 is perfect. 1 times 1. So yeah, this is a perfect square. I like to put a minus and a plus. And then I just go one thing at a time. Up first, 144. What is 144? 12, 12. Okay, I'm just going to write 12 first and 12 first. And then I move to the next thing. The next thing is the x4. We talked about this. We can rip that in half, and we can get x squared, x squared. After that, we have the minus. And the minus means, okay, now it's time to jump to the other side, to the back half. We have a 1. And 1 is always kind of the weirdest one, because what happens if you rip the 1 in half? No. It's 1 and 1, right? 1 times 1 equals 1. So sometimes 1 is like the hardest one for kids because it's weird and you want to put like but never any fractions, never anything like that. We need to do these last three, I promise, before you go. Okay. Number 5. This one, it looks crazy, right? It looks ridiculous. 36 is perfect. X8, it's big, but can we rip it in half? Yes. We have the minus. Yes. 169. That is not on our list. It is bigger than 12. Maybe it's 13. What is SQRT 169 13?
What is SQRT?
Square root. Like to root the square, to break it into pieces. 13 times 13 is 169. And so this is a perfect square. And this one also has y's. Y6. But if we have 6 y's, can we break it in half? Yes. So everything looks good. Go through it one at a time. 36 is 6 times 6. And what about x8? Rip it in half. x4, x4. And what about 169 on the other side of the minus? That's 13, 13, and 13. And what about y6? It is y3 and y3. Or we would say y cubed. But all you have to do is make your pattern, work it out, and then move it through like that. Okay, down here. What if a term is not a perfect square? Look at this. This is for sure the hardest question on the quiz and perhaps even the test that's coming up. Is 3 a perfect square? No. But x squared is good and minus is good. Is 75 a perfect square? No. We actually already said earlier, there's not a single 70s number that is. So 75 is no good. So our difference of squares will not work. You cannot do the parentheses. You cannot do the minus plus. This is a failure. But try pulling out a GCF first. A greatest common factor. Okay. Desmos. Again, I promise you want to see this. Desmos, GCF parentheses. I hope you remember how to do that. 3, 75. It's 3. So let's put a 3 here. Then we have x squared and no x's, which means we're not going to be able to pull out any more x's. And so that's all that we can pull out is a 3. And now, what is left over in the parentheses? Remember, we basically need to divide by 3. What is 3 divided by 3? It's 1. And we also need to divide this one by 3. What is 75 divided by 3? Negative 25. Like 75 cents would be 3/4. Okay, as of right here, we could not do difference of squares. We did not have perfect setup, but we were able to do GCF instead. But look at it now. Look at what we happen to have left over now. 1x squared minus 25. Are these perfect squares? Yes. And so step 2, step 1 was a GCF. Step 2 is going to be a difference of squares. We're going to do our parentheses. We're going to do a minus and a plus. What is 1 split into 2? It's going to be 1 and 1. 1 is kind of that weird one where there's like an infinite 1 glitch or something, but you just kind of square root it. X squared, rip it in half, you get x and x. 25, square root it, is 5 times 5. And this answer is not quite correct.
Why not?
Why not? We did the GCF, and then we did the difference of squares, ripped it into 2 pieces. What we're missing for this question, let me get the red marker here, is we are missing the 3. This 3 right here that we brought out, the GCF, has to come down. I said this is probably the hardest question on the test. GCF, we were really good at, and we did that 2 weeks ago. Difference of squares isn't that hard, and you guys, it might be weird today, but you guys will learn it really fast. The reason this is hard is because students always forget to bring down that GCF. Okay, let's do 2 more questions, and we'll wrap up these notes. They've been a little bit longer than I expected. 18 and 8. 18, minus, okay, that's good. 8, So we do not have difference of squares. 18 is not a perfect square. 8 is not a perfect square. But Desmos, GCF, 18 comma 8, the answer is 2. So maybe if we do a GCF of 2, we will end up with something that comes, and maybe we'll have a step 2. What is 18 divided by 2? 9. What is 8 divided by 2? 4. And now, look at what we have left. Now, this is looking excellent. 9, yes. Minus, yes. 4, yes. X squared, yes. So now, split it. One of them's a minus, one of them's a plus. The 9 is 3 times 3. The 4 is 2 times 2. The x squared is 1 and 1. And this answer is not quite correct. You have to bring down the 2 if you want it to be correct. The very last one, not sure if I have a ton of room for it, so what I'm going to do is just write it a little bit bigger for you guys. I don't want to forget it because it is interesting. It is worth doing. 5x power 9 minus 125x cubed. Well, is 5 a perfect square? No. Is x9, can we rip x9 into 2 equal parts?
Yes.
I don't think we can. We could rip it and we could make it x5 and x4, but we can't split it in half. 125, no good. x3, no good. The only thing good about this is that we have a minus. But maybe we do a GCF. The GCF of 5 comma 125 is 5. So I'm going to take out a 5. Also, this person has 9 x's and this person has 3 x's. So you know what? We can also take out 3 x's from this question. GCF, if you have to watch that video of a reminder to go through how to do the GCF, I'll link it in the comments or something maybe. Once we GCF this, we have to divide by 5x cubed. 5 divided by 5 is 1. Subtraction, 9 minus 3 is 6. Minus 5 and x cubed. 125 divided by 5 is 25. X cubed, 3 minus 3 is 0. At first, this was not looking good, but now it is looking good because now 1 perfect 6 can be cut in half, negative perfect 25 perfect. So now, parentheses, a minus, a plus, 1 makes 1, 1. X6 makes 3, 3. 25 makes 5, 5. And don't forget to bring down whatever your GCF was, 5x cubed. Okay, there's plenty of GCF questions. We're going to end the notes. The reality is, here's where you want to be, okay? You want to be able to see x squared minus 9, think good, 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 parentheses, a minus, a plus, x makes x, and x, 9 makes 3, and 3. If you can do that, if you know what just happened, you're doing well. This question's crazy. This question's hard. I don't expect you to feel like this is easy, but this question is easy. Okay, notes are over. Nice job. You can learn this. You got it.